Hello everyone, we are the members of Software Quality Laboratory at Southern University of Science and Technology. Today I'm going to introduce our work, HmTest, automated testing of HarmonyOS apps via model-driven navigation and reinforcement learning. This is the workflow of HmTest. HmTest is an automated testing framework for HarmonyOS apps consisting of two parts: targeted exploration and RL-based exploration. Targeted exploration focuses on white box testing using static analysis to build a static model PTG, page transition graph, which models transitions between HarmonyOS app pages, and uses DFS to achieve a high page coverage efficiently. When further exploration is needed, the process can switch to additional strategies for testing. RL-based exploration is designed for black box testing, using reinforcement learning to explore apps more comprehensively. It incorporates a DFA-guided recovery mechanism to handle stuck or crash states. It also supports input actions by leveraging a large language model to generate more meaningful text inputs, and all actions are executed through the HDC bridge. Finally, after the testing process completes, HmTest generates a detailed test report to summarize the coverage and the issues detected. Next, let me introduce how to use HmTest. First, clone the project, and make sure these tools and variables are added to the system environment path. Then install the dependencies in requirements.txt. All configurations for the exploration algorithms can be customized in the settings.yml file. Then open the Huawei device emulator or connect a physical device to your computer. Use the command HDC list targets to get the serial numbers of the connected devices. My computer is currently connected to two devices. The first is an emulator and the second is a physical phone, as shown by the output. To run targeted exploration, you need an open source HarmonyOS app project. You need to click this button in DV Studio to get the bundle name, the model name, and the product name of this project. Switch back to the HmTest project and run the command python main.py with some necessary parameters. Use serial to specify the device serial number obtained above, and provide the basic information of the open source projects, such as the project path, the bundle name, the model name, and the product name. You can also specify the testing total time, such as 60 seconds, and you can also input the seed to set the random seed for reproducibility. And then run the project. It first generates the PTG for the open source project. You can see it is doing the targeted exploration automatically. After the testing finishes, an output directory will be generated in the project folder. This directory contains various logs and state information. For open source apps, detailed coverage reports are stored in the report folder within the output directory. Next, I will demonstrate the RL-based exploration part. You can customize various settings in the settings.yml file, such as adjusting Q-learning parameters or enabling the DFA recovery mechanism based on your specific requirements. I will use Weibo, one of the most popular apps in China, to demonstrate how RL-based exploration performs black box testing on a commercial app. You only need to specify the serial number of your phone and the bundle name of the app. It is also doing testing automatically. And an output folder is also generated. It's worth mentioning that our framework is highly extensible. You can customize various aspects in the settings.yml file, such as defining new exploration strategies or modifying the definition of window states. All you need to do is to implement the corresponding interfaces. This is a demonstration of HmTest. Thanks for your listening.